In this video I will give you an overview of how my thrust vector control rocket will work. This is the side view of the rocket. It consists of three parts, namely a parachute ejection system that is currently still not attached to the rocket, and then a flight computer based on the Arduino Nano and some sensors to know where the rocket is going. And then if I unscrew these two screws, also a TVC mount. TVC stands for thrust vector control, and this makes sure the rocket can keep itself upright. So this is the mechanical system that is responsible for keeping the rocket upright. It consists of two servos, each responsible for its own axis. And so this one is the y-axis and this one is the z-axis, and this the flight computers will sense an orientation or a change in orientation away from the desired angle, which is 0 degrees upright, and then it will do a calculation based on previous angles, and based on that it will send a command to the servo and pitch and turn the servo one angle or another, and this way the rocket motor, which will be inserted here at the bottom, will be pointed towards one side, and this will induce a torque on the vehicle. And now this is the body tube. It just easily clicks on here. This is very handy for testing. This way I don't always need to put on the screws. And then this is a flight computer. It slides right in, and this is also attached with some screws. And then the parachute ejection system. And this is based off a design of Jacob Thornhill. I would highly recommend his channel. This is based on a design where you put the parachute in this side here, and then you put the cap on like this. There's a spring right here with I don't know if you can see it, yeah, like this, with a piston, and you you compress the spring like this, and then the servo will turn, and it keeps the enclosure intact. And then when it's time to eject the parachute, the servo will turn around. And right now it's not connected to anything, and then the parachute will fall out. As I said earlier, the flight computer is based off of the Arduino Nano. This is my first flight computer I've ever made. It's relatively simple. It's just a PCB with on which I soldered some components like the Arduino Nano, and then an MPU 6050, that's this one. This will calculate and measure the orientation of the vehicle. We have a BMP 180. This is a pressure sensor and will calculate the height of the rocket. This is a LED. It just lights up and gives you information about the state of the rocket. And then this is a radio module. I have to look up the name, how it's pronounced. It's a long string of letters, and this will keep contact with a ground station, which will be hooked up to a computer, and in this way I will be able to retrieve data from the rocket. Next, it's powered by a 9-volt battery. These are easy to find. They're not as complicated as LiPo batteries. LiPo batteries have a small possibility of catching on fire, and right now I don't want to deal with them, even though they are more powerful for the weight they hold. And then a simple switch to turn it on or off. Right now it's off, and I don't know which program is loaded in right now, but you can see the Arduino will light up, and the MPU 6050 as well.